Okay, so now for question A, number of moles of metal hydroxide is used. So when we're trying to calculate the moles, okay, so it asks us to find the moles of metal hydroxide. And to count moles, the formula that we are going to use would be moles. Moles would be equal to concentration times volume. It should be concentration and concentration. Kind of hard to write this through. So this should be times volume. Okay, so it's a really sloppy handwriting there. Okay, so moles is time concentration times volume. So we know that the concentration is right here. So concentration times volume, we have the concentration of metal hydroxide right here is 0.0600. 0.0600. And then we're going to times that. So the volume there is 20 or 0.0200 decimeter cube. So I don't really have to write the units now. Okay, so here we have it, concentration times volume. And when these two are multiplied, we have 0.00 120. So this is the unit would be in mole. Okay, so for question number A, the answer is 0.00120 mole. So this is the answer for question A. Put it right there. Okay. And now for question B, we're asked to calculate the number of moles of hydrochloric acid. So it basically goes the same for hydrochloric acid. It's concentration times volume. And we already know that already previously. So I'm going to write this down first. So the concentration of hydrochloric acid, we can see right here is 0. Where is it? 0.100 moles per decimeter cube. So that's the concentration of hydrochloric acid. And then here is 24 centimeter cube. That would be the volume, or 0.024 in decimeter cube. So we're going to write that down. Okay, that would be equals to 0.00240 mole. So this is the answer for question B. It's basically the same as question A. When trying to calculate the mole, you can actually times concentration times volume. That would be the formula. And so far, do any of you have any questions? If you have any questions, you can just feel free to ask. Okay. So now for question C, we are asked is now we are asked about the simplest mole ratio of the metal hydroxide to hydrochloric acid. Okay. So since we're asking about metal hydroxide first, so what is the moles of metal hydroxide? That would be 0.0020. Okay. 0.0013 there. So this is the moles of metal hydroxide. So we're trying to find the ratio here. And then the number of moles of hydrochloric acid would be 0.00240. Okay, just like that. So now we can see clearly the ratio over here. So 240 or 24, right here you can see it can be divided by 12. And then 12, it also is divisible with 12. So that would be 12 divided by 12, that would be 1. And then right by here. And then 24 divided by 12, that would be 2. So the simplest mole ratio would be 1 by 2. So this is the answer for part C. So if you have any questions about this, you can feel free to ask. And then for question D, write a balanced equation. Okay, so usually the equation one thing, it's the most difficult of all. Okay, so we can do this. So metal hydroxide is M, okay, should be capitalized. Oh, should be capitalized. MOH, or metal hydroxide. Usually metal would be, M is the symbol for metal. And then we're going to shift this to V plus. And then we can see right here, the hydrochloric acid, it has two. So right there, two hydrochloric acid, two HCl. And there should be a an arrow there. Can you just pretend it's an arrow? Okay, so the end result should be water. So it'll be something, something water usually. So it should be like something like this. So let's just write it to right there. Okay. Usually something like this. Can I actually move this? Okay. So we have H right here, two right here. Oh, so that would leave. So let's just see right here, the H2O. So let's just say we have two hydrogens. So hydrogens should be crossed out. And we have oxygen right here crossed out. So now we are left with M, the metal right here, and chloride, Cl. MCl2. First we get the two right there. So this is the balance equation in the end. Okay. So do you have any questions about the whole part of question number 18? Okay, so if you have no questions about question number 18, we can move on to question number 19. Let's stop sharing first. I think I have to do that. And then I'm going to go back to the materials again. So I'm going to make this quick. Okay, so console calculations involving gas volume. I think we've actually discussed this previously, I'm not really sure, but I'm just going to start reviewing again. So this is called the Avogadro's hypothesis. This idea is probably true as long as the pressure is not too high or temperature is too low. It's convenient to measure volumes of gases at room temperature. We call it RTP for room temperature, and pressure at 1 atmosphere. The room temperature and pressure, 1 mole of any gas has a volume of 24 decimeter cube. So it's universal thing. So here we have it, the work examples. So for question number 22, we are asked to calculate the volume of 0.40 mole of nitrogen at RTP. So the volume in decimeter cube, it's once again is the same, 24 for everything. And then times the number of moles of gases, which is 0.40. So 24 times 0.40, we get 0.6 decimeter cube. Yeah, so 24 is actually a fixed number. It's in the formula because it's basically the same for every gas volume at room temperature. So for question number 23, we have calculate the mass of methane, CH4% and 120 centimeter cube of methane. So the MF value would be 16. So now we have 120 centimeter cube. We're going to convert that to decimeter cube. So we have 0.120. And now we're trying to find the mass right here. So first of all, we need to find the moles first. So the number of moles right here would be the volume divided by 24. The volume here, we have 0.120. We're going to divide by 24. And therefore, we get 5 times 10 to the negative cube, I think, of mole. It's negative right here because it's a decimal. And then to calculate the mass, we're going to the formula of finding mass would be mole times the molar value, or MR here, the molar mass. So that would be 5 times 10 to the negative cube times 16, which is the MR value right here. It's already stated in the question. And that's how we end up with 0.080 gram, 0.080 gram. Okay, so now we are going to question number 19. So I'm going to copy the question first. Okay, I think I need to stop sharing first. Okay, I'm going to stop sharing first, and then I'm going to go back to the board previously. Okay. Okay, so this is question 18 previously. I'm going to delete everything since we're going to discuss question 19. Okay. Okay, so this is really small. Can I? Okay. Okay, so for question 19, there are two parts of question. So there's the A part, which is calculate the volume in decimeter cube occupied by 26.4 grams of carbon dioxide at room temperature. Okay, so we are going to ask to calculate the volume. So first of all, okay, so I'm going to identify first. So the one that we know from this would be the AR value and this right here, the mass of carbon dioxide. Okay, so first of all, we can find the molar mass first, which is the MR value. And to find that, we're going to do this. So MR would be equals to, I'm going to write this again. So the MR value, so MR value of carbon dioxide, here, we have it. So the AR value of carbon would be 12. So we're going to input that 12 and then plus here. So the AR value of oxygen here is 16. But as we can see right here, the carbon dioxide contains two oxygen atoms. So that means we have to times that by 2. So 2, so that would be 2 times 16. So that would be 12. And then 2 times 16 would be 32. So that would be 44. 44, and the unit for molar mass would be gram per mole. So that would be grams per mole right here. Okay, so this is the MR value. So the next one, you're going to okay, so this is a gas here. So the next, after finding the molar value, you're going to find the number of moles. Since the volume here, usually in gas at room temperature, the volume, you actually need to find the moles. So number of moles usually times 24, since it is actually a fixed number for room temperature. Okay, so therefore we need to find the moles of carbon dioxide first. So now to find the moles, we have to do this first. So the moles would be mass over molar mass. So here we're going to write down the mass. Will be divided by the MR value. So for the mass, it's already stated in the question, that will be 26.4. So we're going to write it down, 26.4. Because it will be divided by 44 gram per mole. So 26 divided by 4, 26.4 divided by 44, that would be equals to 0.600 mole. So that would be 0.600. So this is the number of moles after we calculate. Okay. So for the volume here, we're going to write down number of moles. So number of moles is 0.600, 0.600 mole. So this is the unit for moles. And then we're going to times by 24. 24, it's like the concentration is B. Okay. I'm going to actually do this. Yeah, it will be 24 decimeter cube per mole. Okay.
Michelle, what happened with the only 3 standard open the cam? How about others?
I don't know.
Come on, guys. I already wrote that.
Okay, I'm not really sure, but usually most of them will open their cams. But
Yeah.
yeah, my internet is not really stable here, so I actually got kicked out of the Zoom once at the beginning of the class, sir. I'm
Okay.
not sure. Yeah, I'm not really sure why. I need to switch the internet first.
Okay.
Second. Okay, so now, okay, we have here the volume of gas at the usual room temperature, which is 24. decimeter cube over mole. And this is, we have the moles here, 0.600. So here we're just going to cross out the mole here, which leaves the unit to be decimeter cube. This is the volume. Did I just say concentration? It's supposed to be volume, not concentration. Okay. So this is supposed to be 3. Just got really right here properly. So there'll be 0.600 times 24. That would be okay. After some calculation, it's 14.4 decimeter cube. So this is the volume of carbon dioxide. So do any of you have any questions? If not, then I can go back to continue to question B, and then if you have any questions, you can feel free just to ask me. Okay, so if you have no questions for question A, that's okay. I can move on to question B, and then if you have any questions about question A or B, then or you probably need some explanation, like for me to explain things, then this will be okay as well. Okay, so I hope you can see the question here. It's not too small, right? Can I usually? Okay, I'm going to just enlarge the question. Okay. Okay, so I think this one's actually easier than the previous one. So right here, we are actually asked to calculate the mass of helium present. Okay, so first of all, we need to find out what we are given in the question. So we have 120 centimeter cube. So this is the volume. And usually if it's centimeter cube, we have to convert that to decimeter cube first. So 120 will be divided by 1000. We're going to convert the unit first. Okay, so converting the unit, cross this out. So now we are left with 0. Okay, that's way too much. Okay, so that will be 0.120 decimeter cube. So this is the volume of helium. Okay, so now that we have the volume of helium, and we know that the volume of gas and room temperature would be 24. So it's universal. So now we can actually find the moles of helium. So the moles of helium right here. So the moles of helium. And to calculate the moles of helium, needs to do this first. We have the volume of helium right here. So volume of helium there. And we're going to divide this by 24, since it is the formula of this gas temperature. So I don't write the units, but it's actually more suitable if you need to write units. Now it's better, to be honest. And now we have 0.120. So this is the volume. So we are going to divide this by 24. And now the result would be 0.00500 mole. So So I don't think the other zeros would be necessary. You can actually just write this down. And don't forget the unit of moles. Moles would be mole, which is MOL, in lowercase. So this is, we find the moles. Now we're asked to find the mass here. So you know that mass is moles times the MR. MR right here is molar value. It's usually a compound. We're just going to calculate every atom right there. But now we know that helium right here, it's only one, like this singular is not a compound, it's just a single element right here. So the molar value and the AR value would be the same, so that would be 4 as well. So therefore, the mass would be moles of helium, so the moles right here we already find is 0.005. Times the molar value, or since in this case helium is a single element, that would be the area values be the same, so that would be 4. So there we have it, 0.005 times 4, that would be 0.002. And the unit for mass would be grams. So that would be right here. 0.0200 grams. So this is the mass of helium present in the flask. So do you have any questions about number 19? So if you have any questions, just feel free to ask. Okay, since none of you have any questions, that's okay. We can move on to the next part. So I'm going to stop sharing first. Okay, and then I'm going to go back to our materials. So this is actually the last part. Okay, so I'm going to start sharing again. Hold on. Okay, so it's the gas volumes and stoichiometry. We can use the ratio of reacting volumes of gases to deduce stoichiometry of a reaction. If we mix 20 centimeter cube of hydrogen with 10 hydrogen oxygen and explode the mixture, we will find the gases exactly reacting together, no hydrogen and oxygen remains. According to Avogadro's hypothesis, equal volumes of gases contain equal number of molecules and therefore equal numbers of moles of gases. So the mole ratio of hydrogen to oxygen is 2:1. So it will be something like this. Okay, so I'm actually going to zoom out this out first. Okay, so I'm going to go through the work example first before. Okay, so 24 right here. When 50 centimeter cube of propane reacts with exactly with 250 centimeter cube of oxygen, has 150 centimeter cube of carbon dioxide is formed. So you have propane plus oxygen. So propane here is 50 and then oxygen here is 250. Will react and make carbon dioxide 150 plus water. So this is the ratio. It's 1, 5, and 3. As 1 mole of propane produces 3 moles of carbon dioxide, there must be 3 moles of carbon atoms in 1 mole of propane. So it'll be something like this. The 5 moles of oxygen molecules are used to react with both the carbon and the hydrogen in the propane. 3 moles of these oxygen molecules have been used in forming carbon dioxide. So 5 minus 3 equals 2 moles of oxygen molecules must be used in reacting with the hydrogen to form water. There are 4 moles of atoms in 2 moles of oxygen molecules, so there must be 4 moles of water formed. So something like this. So it's basically just a ratio of the number right here. I hope you can understand this, to be honest. Okay, let's me just try to explain this again. So 5 moles of oxygen molecules are used to react with both the carbon and hydrogen propane. So 5. 2 moles of oxygen molecules be used, so there will be 5 minus 2. This is how we end up with 2 right here. Moles of oxygen molecules must be used reacting with hydrogen to form water. There are 4 moles of atoms in 2 moles of oxygen, because there must be 4. So this is why it ended up with 4. I'm not sure. This sounds confusing, but it's not really that hard, to be honest. But okay, so we're just going to go with question number 20. I hope that by explaining it to question number 20, it can be more understandable. Let's stop sharing first. Okay. Okay, I'm going to put all this. Right. Okay, so first of all, we have right there chlorine right there. Phosphorus reacts to chlorine. Okay. Okay. Okay, so right here we have question A. How many moles of chlorine react with 1 mole of the gaseous hydrate? So to find this, we need to find the volume of chlorine first. So volume of chlorine will be 150. So I'm just gonna write this 150. This is the volume of chlorine. So then we divided the gaseous hydrate is 50. So 150 by 5, that will be 3. I mean 150 divided by 50, that will be 3. So 3 is number of moles right there. So 3 moles of chlorine react with 1 mole of phosphorus hydrate right here. So the answer is 3. So that's for question A. So now number B, deduce the formula of the phosphorus hydrate. So right here we know that for each chlorine here it's 1 mole, that'll be 150, and so chlorine reacts with hydrogen usually in a 1:1 ratio. And then right here number of moles of hydrogen. Okay, so instead of doing this, okay, I actually wrote down notes, it's kind of confusing. So just me explain this and put it this way. So we have 150 right here. This is 1 mole of chlorine. And then right here we have 50 with the gaseous hydrate. So now we're trying to find the formula of gaseous hydrate. So that would be pH something. So the N is the unknown value, so it would be pH something. So we already can tell from question A. So question A and B is subsequent. And since the answer is 3 right here, so for each chlorine react, so moles of chlorine react with 1 mole of gaseous hydrate, that would be 3. So that would be pH 3. So that's the answer. pH 3, 3. So now we're just going to write the balance equation. We're just going to type this out. So the balance equation will be capital, so pH3 plus, so this is 3 chloride. So this is supposed to be like a 1:1 ratio, but chloride is like 3 times, so that's why it becomes 3 chloride. And then here, okay, hold on. So okay, we need to remember this to the mole ratio. Okay. Okay, so it's never going to be water. Okay. Like, do I go back? Okay. So this would be equals to, okay, let's just resize. So this would be PCl3, right? Yeah, 3 plus V3 HCl3Cl. Okay, so this is the end result, the equation. You probably learned this balance equation advanced high school, something like that. So I guess this is all for question number 20. Do you have any questions so far about question 20? Okay, so if you have no questions, I'm not sure if you can actually see the screen jumping. So I'm just going to stop sharing this, not to speculate. Okay. So this is the whole summary of what we've learned in chapter 1. Since next week we're going to go to chapter 2. So you guys can actually read this. I'm going to share it. So this is the end of chapter question, which will be your homework, but don't worry, I'm not going to assign every number to all of you. Assign every number, just going to pick one number, and that will be your homework. And I think just going to give you guys a week to submit this before our next class next week. So I hope that sounds good to all of you. And I think we can end this class earlier. I will share the summary and then the question for your homework next week. Okay, so I'm just going to stop sharing. Do you guys have any questions about this material first before I end the class? So no questions? Okay, so if you have no questions, then okay, I'm going to stop. We just stop